Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend.
This video is for grade 11 students in Functions and Relations working on the year-end summative. It's question 2.
A baseball is hit from an initial height of 0.8 meters and its path can be modeled by this equation, where h is the height of the ball and d is the horizontal distance it has traveled from the batter, both in meters. So I'm going to try to understand as much as I can about this equation, and then I'll see what I'm supposed to do with it. So obviously I can see that it's a quadratic equation, and it is a negative parabola. And again, that makes sense because as a projectile, a ball hit in the air roughly does this. And because it's a parabolic curve and it's negative, that's the shape of the parabola. I also can tell that, I can tell here and here, same information is given to me that the ball starts zero point 0.8 of a meter above ground. So if we think about this as a quick idea about what's going on in this question, oh, that's not a very good line. Let me use one of my fancy technology tools here. So if we think about this as a potential graph, then what we have, hey, not bad. So what we have is we have a projectile, and it starts zero point 0.8 of a meter above the ground, and then it goes up to some sort of maximum, which would be the vertex, and then at some point it hits the ground. So distance over here and height over here. So a lot of times you would study this as a time versus height, but this is a horizontal distance height. So there's a lot more visuality to this one. Visuality. Nice. Okay, you can use that word if you want. Okay, so that's what's happening. Quadratic equation, something like this is going on, and what I need to do is find the maximum height of the ball and the distance from the batter at that maximum height, I assume, to the nearest tenth. So to find the maximum height, we know what that means. It means find the vertex. So we're going to have to find the vertex of a quadratic equation. So let me just go to the next screen so it's nice and clean. How do I find the vertex of a quadratic equation? There's several methods. You could complete the square. You could try factoring. I'm going to use kind of the method I always use whenever there's decimals and strange numbers like that involved, which is I'm going to use the Pythagorean, nope. I'm going to use the quadratic equation to find the roots. So I'm going to find the roots. And once I know the roots, I can find the axis of symmetry. And that's because the axis of symmetry is exactly at the midpoint between the roots. The axis of symmetry tells me the coordinate, the first coordinate of the vertex. So by finding the roots, that will tell me where the axis of symmetry is, which will then help me find the vertex. So to find the roots of this equation, we need the quadratic equation. So we know the quadratic equation, d equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Okay, so that's the equation, and now I'm going to substitute the values in from ax squared plus bx plus c. So this would be negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. And again, I say again because I'm assuming you've maybe watched some of my other videos. You'll notice that I wrote the equation with blank brackets and then I substituted in, and that's just because it's way too easy for me to copy the wrong value into the wrong spot if I'm trying to focus on both writing the equation properly and substituting in. My brain doesn't really like that very much. Stupid brain. But that's not a bad thing. My brain does some other things well, just like yours. So feel free to borrow that little trick. In fact, if you've ever made a mistake with just substituting in the wrong value, maybe that's not such a bad idea. Okay, so I'm going to calculate all of this at once in my calculator. So if you want to listen along, 4.9 squared minus bracket 4 times negative 0.15 times 0.8 close bracket equals, and that's going to be 24.49. And in the denominator, I'm going to have negative 0.3. So at this point, I'm going to calculate the square root of 24.49 and split it into two different roots. So one of them is going to be the plus. So if I take the square root, what do I get? I get 4.94. Good. Actually rounded correctly, 4.95. So 4.95 divided by negative 0.3. And the other one will be if I do d equals, ooh, that was a bit messy. D equals negative 4.9 minus 4.95, all divided by negative 0.3, and then just calculate each. So over here, I get a d value of negative 0.17, and over here, I get a d value of 32.83. So again, make sure that your answers make sense. If I go back to the diagram for a second, um, one of my um, one of my roots was actually a small negative number, and that's because of this right here. Because the ball itself starts slightly above ground, which means that for the parabola, there is another root, it just happens to be in the negative distance. So the reality is that the ball only really hits the ground once because it doesn't travel backwards and forwards. But we're going to need that calculation anyway. So one of my roots is here. It was negative 0.17, and the other root is over here at 32.83. And don't forget, this isn't time, this is distance. So the ball wasn't in the air for 32 seconds. That would be quite an amazing hit, 32 seconds. But it's the distance that it travels, which is 32 meters away. So, but remember, the goal wasn't to find the roots. The goal was to find the vertex. So we're going to use the roots to find the vertex. So now that we have the roots, we're going to find where the axis of symmetry is. And the axis of symmetry is a line. Ooh, close enough. The axis of symmetry is a line that says x equals something, and that something is the midpoint of the roots. So let's calculate the midpoint of the roots by adding them and dividing by 2. Midpoint is basically finding the average of two numbers. So when I find the midpoint of the roots, I get 16.33. So my axis of symmetry is a line at 16.33. And again, if we look at the diagram, this would be the axis of symmetry, and that's at 16.33 meters. So the axis of symmetry passes through the vertex, which means if d equals 16.33, I have my maximum. So that's the next step. Now that we know where the axis of symmetry is, we're going to find h at 16.33. And so the equation was negative 0.15d squared plus 4.9d plus 0.8, and d was 16.33. So if I calculate all that out, I get a value of 40.8 meters. And I think that was all I needed to do, right? Find the maximum height of the ball and the distance from the batter. Okay, so the maximum height was 40.8 meters. 40.8 meters. And the ball was 16.3 meters from the batter. Oh, that was fun. When it reached maximum height. Okay, so that's part A. Pretty straightforward, quadratic, find the vertex question. How far away is the ball when it is 10 meters high? Okay, so let's rethink our diagram here. So here is the ball being hit and then landing on the ground. And we remember that this is about 0.8 meters above the ground. At some point, the ball reaches 10 meters in height. Now it's going to actually reach it twice, once on the way up and once on the way down. So we need to find out what is d when the height, oh boy, that was weird. What is d when the height is 10? That's the math we need to do. So we're going to take our equation, we're going to sub 10 in for the height, and then calculate d. Like this. So how do we solve a quadratic? Well, no matter what, we need it equal to 0. So I'm going to subtract 10 from both sides. And then once I subtract 10, I can decide what strategy to use. And I think, again, I'm going to use the quadratic equation to solve for d because it's the most direct. That's exactly what it does. So d equals negative b plus or minus the square root of d squared minus 4 times a times c, all of this divided by 2a. And now the values, so b, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And again, calculating that out, I get, I'll just fast forward a little bit because you've seen plenty of examples of this, and if you need more help, then you can ask for more help. Haha. So when I calculate this big square root number, I end up getting 4.3. So one root would be negative 4.9 plus 4.3 divided by negative 0.3. And the other one would be negative 4.9 minus 4.3 divided by negative 0.3. So I get d equals 2, and I get d equals 30.67. And again, it makes sense for them both to be positive numbers because the first one happens here. Let me grab a different color. The first one happens here, so that would be at 2 meters away from the batter. And the other one happens here, which would be 30.67 meters away from the batter. Okay, so the ball reaches a height of 10 meters twice, once 2 meters away and once 30.67 meters away. And there's one more part to this question. If a person was 31 meters away from the batter, could they catch the ball? Well, let's think about that. We know that at 30.67 seconds, at a distance of 30.67 meters, the ball is 10 meters above the ground. Right? So this is 31, and this is not quite 31, and it's 10 meters above the ground. We also know from part A that the ball hits the ground at, what time does the ball hit the ground? At this number, 32.83. I keep saying time, I apologize. I'm just used to those questions where it's time and height. So we know that at a distance of 32.83 meters, the ball hits the ground. So from this, I know that the person who is 31 meters away, the ball is going to be between 10 meters high and 0 meters high, which means someone who's reasonably decently athletic could reach for the ball either up or down, depending on exactly where the ball is. So I would say that yes, a person 31 meters away could catch the ball since the ball will be less than 10 meters above ground, but not yet on the ground. I think that'll do. As long as I have my actual mathematical references here, this can be all kind of non-mathematical sounding. Okay, so I hope that helped. Another quadratic question